Hello and welcome to this lesson. Today we are going to learn the topic of numbers, mathematics, for grade 8 learners. So this lesson is suitable for grade 8 learners, although grade 9 students can also watch the video. Now, the topic of numbers. This topic, if you look at this book, we are going to rely both on this book and of course grade 7 content, because I understand most students have not gone past the first topic in grade 8. So if you open this book, the first topic is numbers, and the topic is also repeated from grade 7, although different content is taught under that topic. So the lesson today will cover both grade 7 extensively on numbers and grade 7 and grade 8 integers. We might touch on fractions, but we are going to look at decimals. In grade 7 there is prime numbers, LCM, GCD, and identifying different types of numbers. For example, in grade 8 there is these integers. Other textbooks that we are going to rely on, we are going to use my book. This is my book, Excelling KJSEA Mathematics Workbook. Has many sample papers that mirror the final exam at grade 9. There is content for grade 8 and grade 7 that you have covered already. For this specific lesson, we're also going to rely on examples from this book. This is a homework assignment book, and the most recent KCSE paper, KJSEA, sorry. I teach mathematics for both senior and junior. That's why you will hear the confusion of KCSE and KJSEA. However, we are going also to use a certain paper here for grade 7 that has many examples on the topics that we need. I can see almost question 1 to 4, even question 8 and 9 are from these topics. So this is how you are going to do. I'll give you a question, maybe it will be displayed here, sometimes I'll write on the board. The best way to revise is by doing, especially mathematics. Mathematics is a doing subject. When I write a question, you pause, you attempt, and then when you are done attempting on your paper, you unpause the video, and now you mark for yourself, or you go through perhaps an area that you didn't know, you learn. That is very important, that you make sure you attempt each question. So I intend to do this for about an hour, so therefore the lesson should be around an hour and a half. Shouldn't go past 1 hour and a half, because again you need breaks. If you find it too long and you feel tired along the way, feel free to pause the video, take a break, 10 minutes or 15 minutes, then come back and continue with the work. So therefore, this lesson is aimed at addressing basic concepts in mathematics in junior secondary school. We are going first to look at what KJSEA exam had in terms of this topic of numbers, so that again it can motivate you and give you a background of whatever you are learning is testable at the end of the of your course in junior secondary. So I have already uploaded solutions for question 1 up to 10 on my YouTube channel. By the end of this week, all of them will be uploaded. Already by today, this is Monday, 6 of these questions are already available on the channel. The rest are scheduled to appear from tomorrow up to Friday, every day 6 p.m. So therefore I'm not going to repeat the first questions here. However, I'm going to highlight and show you the questions. So question 1 asks, question 1 is about identifying prime numbers. That is the topic of numbers in Form 1 in grade 7. The second question requires you to understand the knowledge of LCM and GCD. The third question is about integers. This one is in grade 8. Knowing how to subtract to deal with the number line. It's both in grade 7 and grade 8. Then we have fractions. Fractions is in grade 8. And I'm sure you have probably done it, or you have even had some fractions in lower levels, grade 7 or even grade 6. Question 5 is in grade 9. So we are going to focus first on the first 4 questions, and then a question that I have not uploaded yet and that we are going to use is section B. Remember, question 1 to question 20 have multiple choices, A, B, C, D. However, from question 20 up to question 40, sorry, question 21 up to 40, it is structured questions. There are no choices. So for this video, this particular video, we are going to do question 21 and question 22. Remember, I have said question 1 up to question 4 are available on my channel, the latest videos that are there, so you can watch them. However, we are going to highlight just a few. For example, the first question here asks about identifying prime numbers. Here you have two. Let us just highlight what prime numbers are. Prime numbers. You are told to identify prime numbers between 2, 4, 5, and 9. And in another book that I have here, you are told to highlight prime numbers, to circle. I think that question somewhere else. It is the second bit. So circle all the prime numbers. Circle all the prime numbers. So you're given 9, 41, 27, 37, 51, 59, and 72. So the first thing, at KCSE, they had told you to pair. You just identify 2, and then the choices, the KJCE, sorry, they had paired 2 numbers. So I had a blue marker pen here. I will use this one. So what are prime numbers? Prime numbers are numbers that are greater than 1 and which have only 2 factors. I know in school you are told, or simply to say, that these numbers are only divisible by 1, and a number that is only divisible by 1 and itself. So again, only 2 factors, 1 and itself. And that number must be greater than 1, so 1 is not there. So what are those prime numbers? We can begin with 2. 2, you cannot divide by any other number apart from 1 and 2. What about 4? 4, you can divide by 1, divide by 2, divide by 4. So this one is not a prime number. This one is a prime number. What about 5? 5, you can divide 5 by 1. Can you divide by 2? No. Divide by 3? No. Divide by 4? No. Divide by 5? Yes. So this one has only 2 factors. It's a prime number. You can go to 9. 9 you can divide by 1. You can divide by 3. You can divide by 9. So this one is not a prime number. So the prime number was 5, 2 and 5. So on the choices you would have chosen where there was 2 and 5. Imagine now you would have gotten that mark correctly. 2 and 5 would have been B. So you can watch the video on my channel again to get a more depth on the same. However, now let us look at this one. So we have already defined a prime number as a number that has only 2 factors, or that is divisible by 1 and itself. So among these numbers, we have already shown in the question that I have wrapped here that 9 is not a prime number. This is not a prime number. What about 41? 41 you cannot divide by 1, 2, 3. You can just try with your calculator or in your rough work. You'll find that 41 is a prime number. It cannot be divided by any other number apart from 1. 41 has this prime is a prime number. Only 1 and 41. So 9 is divisible by 1, 3 and 9. What about 27? 27 is divisible by 1, 3, 9 and 27. You can divide 27 by that. The moment you identify that it can have another multiple apart from 1 and itself, you just cancel it. You don't have even to identify all this. I'm just doing this for the purpose of illustration. So this one is not a prime number. What about that 7? That 7 is only divisible by 1 and that 7. So this one is a prime number. What about 51? 51, it is divisible by 3. If you add the divisibility test of 3, you add 1 and 5, you get 6. So you know it is divisible by 3. So this one is not a prime number. Don't even bother writing all of them. 59 is a prime number. 72, the moment you see a number ending with an even number, ending with 0, 2, 4, 6 and 8, just know that apart from 2 itself is a prime number, but any other number that is even, it means it is divisible by 2. All those other numbers are divisible by 2, therefore they cannot be prime. And prime numbers are only those that have this. Now, let me give you an assignment. Identify all prime numbers between 1 and 50. Identify all prime numbers between 1 and 50. If you are using your phone to watch this video, you can comment, or a laptop. However, if you are using a TV, you'll need to send me maybe a message on the same. Identify all prime numbers between 1 and 50. Let us look at some questions here. Question 21, KJSEA 2025. This is the paper that was done by grade 9 candidates last year. Question 21 was asking, Anita, let me read while it is here so that you can also read. Anita, a grade 7 learner, participated in a 1,000-meter race. She ran 6 not 1,000, 10,000 meter race. She ran 6,784 meters and walked the remaining distance. Work out the distance that Anita walked. And then part B, write the distance that Anita ran in words. Then part C, write the distance that Anita ran rounded off to the nearest hundreds. So you have met this question many times. I know you have met similar questions in your exams. Now, you are told that Anita participated in a 10,000 meter race. So this was the total distance. However, she ran at this point you can pause the video and try to attempt the question in 2 minutes, then you continue watching. She ran 6,784 meters. So then she walked the remaining distance. So what was the remaining distance? You know this was the total and you have run this distance. So the remaining you supposed to subtract. Suppose you are moving from here to here and you run up to this point. It means you have walked the remaining distance. So you take this, from here is 0 and this one is 10,000 and this is 6,784 meters. So what remains is 10,000, you subtract 6,784. So let us subtract. Subtract 4, impossible, so you borrow. You continue borrowing up to you get this point. This is 9. 10, you borrow 1, it remains 9. When it is here, 10, borrow 1 again, remain 9. This 1, sorry. So this 10, you borrow 1, you get 9, again 10, so this is 10, the last one is 10, minus 4, 6, 9 minus 8, 1, 9 minus 7, 2, 9 minus 6, 3. So this is the distance that she walked. So part A is 3,216. Then you are told write the distance that Anita ran in words. So this one, write this in words. It is important to know how to write these figures both in words and in numerical form or in numbers. So this one is 6,000. 6 is written like that. 1,000. And it is not thousands, it is 1,000. 700 and 84, like that. $6,784. Okay. The last question, part C, write the distance that Anita ran round off to the nearest hundreds. So this distance that Anita ran, 6, so you are told to round off 6,784 to the nearest hundreds. So again, if you had not attempted this, you pause the video and then you do, and then we check. So the first thing to do is to understand the place values of these digits. So this one is ones, tens, hundreds. This one is thousands. So the question is telling you to write to the nearest hundreds. So to the nearest hundreds, this is the positions where you are supposed to have numbers, but the rest should be 0. So when you realize that this one needs to be 0, you look at the number just before the hundreds. This one. You ask yourself, if it is either 5 or above, you will add 1 here. If it is below, you don't add anything here, you just put zeros here. So you have 6784. So we want to round off to the nearest hundreds. So you look at the number behind, just before hundreds, which is the tens. So if this is 5 or above, you add. So is 8 greater than 5? Yes, it is. So it meets the criteria. You add 1 here. Your answer will be 68. Suppose the number here was 67 and 49, like that. You look at this. This is below 5. In fact, you roughly told, it's like asking yourself, uko na 6749. Hiyo 49 imefika 50. Imefika 50 ndo uipandisha ikue 100. Kama haijafika 50 unaachana nayo. So ni 49. Hii ilikuwa itakuwa imebaki tu kidogo ifike 100. And that's why you are saying, why do we have to round off, by the way? When you go and buy a shirt or a bag or something, you go in the shop and you buy something at this price, 999. Yani umeenda na 1000 ukarudishwa shilingi moja. You don't burden people with telling them, I bought this shoe at 999 shillings. No, you just say, actually bought this shoe at 1000. You are not lying. It is actually 1000. You are not. The only thing that you are not doing is that you are not being very specific. It's just 1000. Or even if you had bought it at 1001. No, 1001 should be written like this. 1001. This is just 1000 shillings. This one, someone can just say, I bought this at 6,700 instead of burdening people with 84 shillings. So you can say 68, not 67. Say 68, 6,800. For this one, you would just say 6,700, even though you know you added 49 shillings more. And this is the purpose of rounding off. For example, you do not want to burden someone by telling them the population of Kenya is, I'm just guessing this figure, is 59,677,201. You do not want to burden someone with this figure. You just tell them, by the way, do you know Kenya today we are 60 million? Because you have rounded off to the nearest millions. You look at, okay, let me round off this. You look at the number behind it. Is it more than 5? Yes. So you add 1 here. It becomes 60 million. An exercise for you. Round off. Round off. Round off the following the distance, round off the distance Anita walked to the nearest thousands. Round off the distance Anita walked to the nearest, in brackets A, thousands, part B, hundreds, and part C, tens. Yes, so let us round off this number to the nearest thousands, hundreds, and tens. You can pause the video and then unpause and watch my working. Good. So I'll assume you have attempted already. So to the nearest thousands, you write this number. This is 3, 2, 1, 6. This is the thousands, because this is ones, tens, hundreds, thousands. So to the nearest thousands. So you look at the number before thousands. Is it 5 or more? No, it is below 5. So therefore you just drop this and your answer is 3, 0, 0, 0. We go to nearest hundreds. So this was the number, the distance Anita walked. To the nearest hundreds, you say this is ones, tens, hundreds. So you look at the number before hundreds. And this number is below 5. So therefore, you just add the zeros. 3, 2, 0, 0. So, do you see, when you round off the number to the nearest hundreds, you are giving the number at least with 100. And it is not, by the way, a must. You remember the one I gave for the nearest thousands? The population of Kenya, which was 59, and to the nearest millions, it went to 60 millions. So it depends. We will see. We will see, because suppose this was 9. Suppose this number is 39, and then you have 99, or even 50, 51. And you are rounding off to the nearest hundreds. If you add 1 here, it becomes 0. So this is 0. Again, 0, carry 1, 4. So we are going to do an example on the same. So if you add a 0, this one will be to the nearest hundreds. Remember, this was 3,900. The next 100 actually is either 3,900 or 4,000. Yes, you just add the next 100, I mean. You just add to the next. So, here, this is correct. Just note that this one you're giving is thousands, this one is hundreds of thousands. What about tens? 32, 16. To the nearest tens, this is tens, you look at ones. If ones is 5 or more, and here it is more, so you add 1 on the other end. You have 32, 2, 2, 0. Oh, this is 32. Yes. Yeah, so this is 3, 2, and 2. This is correct. I'll give you this as something you can attempt. Lastly, because of this part, round off round off to the nearest uh, to the nearest thousands to the nearest thousands and 2 to the nearest tens. Yes, this one is actually a very good example. So you can pause and attempt. This one is a tricky one, but very easy again. Pause and attempt. I'll assume now you have attempted. To the nearest thousands, you have 4, 9, 9, 9, 9. Where is our thousands? It is here. So you look at the number before it, and you put all these zeros and this one 0. Then if this number is greater than 5, you add 1 here. So you'll have 0 and 5. What about to the nearest tens? To the nearest tens, you have 49, 9, 9, 9. This is our tens. You look at the ones, whether it is greater than 5. And yes, it is. You add 1, so you have 0, 0. When you add 1, here it is 10. So after 10, there is nothing else you are adding. You are just making sure that you have added correctly. This is 10. 0, carry 1. 0, carry 1. 0, carry 1. 50. Did you know that you have rounded off these to the nearest tens? Because if you read correctly, looking at these figures it could be confusing, but if you read correctly that this is actually 1 bob remaining, ndio hii pesa ifike 50,000 ama this figure. So this is 49,999. To the nearest tens would be equal to the same, the same as nearest thousands. Anyway, for your exam, they might not bring a very tricky one, but it is important to understand this concept. Remember, we are not learning just for the exam, but also to understand really what this is all about. So we are done with looking at those figures. Now we can look at something here. So let us look at LCM and GCD. Before that, we can look at something I had seen related to LCM, place value and total value. Yes, this one is better. Now, we are asked what's the difference. What is the difference in the total value of digit 4 and digit 6 in the numbers? So and then you are given those numbers. That is question 3. So what's the difference in the total value of digit 4? So you are given this number 4, 3, 5, 6, 7, 5. So the difference in the total value of digit 4 and digit 6. So what is total value? Total value. There's a difference between place value and total value. When you're talking about place value, you say this one is ones, tens, hundreds. So we can have it here. 12, 4, 3, 5, 6, 7, 5. This is ones, tens, hundreds, tens, thousands, sorry, thousands. This is tens of thousands, tens of thousands. This is hundreds, hundreds of thousands. This is millions, and this one is tens of millions. So this, as you are saying, these are the place values. However, the place value does not necessarily mean is the total value. It's actually not the same. However, it can help, it can guide you. When you are saying this is tens, it means that here we have 5, like if you are counting shillings, we have 5 shillings. Here we have 75. So we have actually 70 plus 5. So on the tens, it is 70. What about 6? 6, we have 600 plus 75. Or you can say 600 plus 70 plus 5. So if you are asked about the total value of digit 6, you take 6 and then zeros to the other part. So 6 is 6 and 0, 0. That's the total value. Digit 4, 4. So when you are asked, so this is 4, then 0, 0, then 0, 0, 0. This is the total values. And now you are asked to find the difference in this total, in the total values of digit 4 and 6. So you can pause the video and do that. Yes, it is, you are subtracting. Subtract 4,000, you take away 600. Yes, so what did you get? Confirm whether you got this. 0 minus 0 is 0, 0 minus 0 is 0, 0 minus 6 impossible, so you borrow 1 here. So you borrow 1, it becomes 10, borrow 1 becomes 9, borrow 1 again. So 10 minus 6 is 4. Then the rest you just drop them the way they are. So that is the answer that was required in that area. Another one is you are asked what's the place value of digit 18. So what's the place value of digit 18? 372.082. So you are being asked about the place value of digit 8. Remember, we had done without the decimals. And without the if you have a decimal from here going this way, this one is ones, tens, and this one is hundreds. What about here? What do we start with? You always you are guided by the decimal. Going this way, you start with the ones. What about here? You do not have a 1th. You have 10th. This one you start with 10th. Tens, hundreds, and this one is thousand. So you after 10 you add THS, 100 THS, 1000 THS, so that it reads tenths, hundreds, thousands. By the way, have you ever ask yourself, why do we start with tens instead of ones? Let's do an example. If you have 0.1, this one, let me use another number. 0.2. We are saying 2 is tenth. Why? Because if you are writing as a fraction, this one is the same as 2 over 10. So this is like a tithe. If you have had tithe in church, we say 1 over 10. That tithe is the tenth. So this one is tenths. What about this one? Why is it hundreds and why not should have been the tenth if you are going this with the second one? So if you have 0.08, just an example, this one can be written as 8 over 100. So this is a hundreds. So this tens, hundreds, and so on and so forth. That's why we use that term. So I believe we have done so much. So I'll give you this one as an assignment just to check on your understanding. I would like to hear your answer on this. So you are told to write this in words. 7,000. Sorry, I'm actually reading it. I shouldn't read so that you... So you are told to write this one in words. I would like to hear what you would say on that. Oh, what are just something. If you have this, if you are told to write this in words, although I've not seen it in your exams, this is what you should say: 372.082. These ones from the decimal, you mention those digits one by one. 0.082. Don't say 0.082. Or suppose this one was 9. Don't say 0.982. I'm a 982. No. Just say 300 and 72 point 9 8 2. Just that way. I hope time will allow us to do a few LCM and GCD and demonstrate to you how it came to in the exam. So you start first with the question that came in the exam. You look at it. And then we go to other questions. So as I had said, this question is well solved in my channel. There's a video I have solved. However, I'm just going to explain. So this question reads, there are 120 boys. There are 120 boys and 180 girls and 24 teachers in a school. The school formed groups with equal numbers of boys, girls, and teachers. What is the largest number of groups formed? What is the largest size of groups formed? So, when you hear the word, what is the largest size, what is the smallest number, you know there is something they want to use, the GCD or the LCMs. So you have, this school has boys, 120, girls, 180, and teachers, there are 24. So the school is forming groups. such that there are equal number of teachers in these groups. There are equal number of boys. If you have, suppose you have 12 boys here, boys, you must have 12 boys, 12 boys. You can have 2 teachers, 2 teachers, 2 teachers. You can also have 5. The number of girls is more. You can have 18 girls. This one is a guesswork. I'm just using this one to demonstrate. And maybe you have many more groups. I didn't say there are only 3. There are many groups. So we are asked, what is the largest number of groups here formed? So when you hear the word largest, many people will go for the GCD. And it is indeed true that the GCD is the greatest divider. So the number of groups that can divide, that this number of people can be divided into, you're going to have 120. You can have 120 there, 180, and 24. So if you take GCD, how do you do the GCD and the LCM? That's why we started with about the prime numbers, because you are supposed to start with the prime numbers. You start with the simplest, which is 2. Is there any number that you can divide by 2? Yes. This is 60. 180 divided by 2, 90. 24 divided by 2, 12. And of course, if you are good with the GCD, you can just pause the video, and then you confirm with what I've done. So I'll continue. 2, 30, 45, 6. This for the GCD, greatest common divisor. It must be common, and this one is important, divisor. So it's a number that can divide. If there's a number here that you cannot divide by 2, we stop using 2. We go to the next one, which is 3. 3. That divided by 3, 10. 45 divided by 3, 15. 6 divided by 3, 2. Is there any other number that can be used amongst the 3? Especially when you look at the last one, 2. And you cannot use a factor that is greater than 2 to divide this one. So you cannot use 5, 7, or 11, 13, or the other numbers. So this is where your GCD ends. I'll explain to you what these numbers mean, the last ones. So GCD, 2 times 2 times 3, which is 6, 12. So the number of groups that you can form is 12. So that you are going to have if you divide by 12, each group will have how many boys? 10. 10 boys. Girls, if you divide by 12, 180 divided by 5, you are going to get 15. So if each group is going to have 15 girls. What about teachers? They are 24, and we have 12 groups. So each group is going to have only 2 teachers. So, well, this is the answer for that question. However, the next exam you might be asked, how many teachers are in each group? The answer will be 2. How many girls are in each group? The answer will be 15. So you will need to find the LCM, the GCD, then take the number of girls divided by the GCD. Or you can simply come and know it is this one, because this one has already, 180 has already been divided by all this. The same with this, and the same with this. This question is very, very, very common. I have also predicted it in my book. My book has several similar questions. However, I would like us to look at this question. You read the question. Maybe you can write in your book, pause the video and do and attempt question 5 here, which reads, question 5. Kiru's plot of land is in the shape of a rectangle measuring 84 meters by 48 meters. Posts are to be fixed along the sides of the plot. What is the greatest distance between the posts? What is the greatest distance between the posts? So you are going to attempt that question and also add I'll add another question. Instead of what is the greatest distance, maybe they could ask, what is the least number of posts that can be used to fence this land? Yes. So I'll assume you have paused the video, you have attempted, and now you want to mark for yourself based on what I'll do here. So Kiru has this plot of land. This side, the length is 84 meters, and this one is 48 meters. You are told that posts will be fixed along the sides of the plot. So you are going to have a post here, another, like that. So if these posts are to be equidistant, so the distance between one post should be the same as the distance between the other posts. So you are asked, what is the largest distance that will be used? So we want to know the distance here. This is pretty easy. You have 84 and 48. So this question has two parts. First, do you know how to do the LCM? And do you also know how to do the GCD? The other part is to understand a question, especially nowadays. Let me tell you, I've been teaching KCSE students at Form 4. One of the greatest challenges they have is reading these questions, comprehending and interpreting those questions. If you look at the previous years, I'm telling you, some students in high school will look at your paper and they'll be surprised, because there is no simple question like figures. You are told a story so that you can read and interpret. And it is not difficult. It is a very simple. Some will just want something like this diagram. However, here you are given a story, you interpret for yourself. You know whether you are going to use GCD or the LCM. Previously, you would be asked, find the GCD of 84 and 48. We are assuming now you are beyond this, and that is why we are giving you a story. You read, understand, and interpret. So, what are we going to use? Is it LCM or GCD? So, the distance that should be the same here, and also the distance that should be the same between these posts, the greatest distance will be the greatest divider. The greatest common divider. Common because you are using two or more measurements to compare. Because if it's maybe one, here you could use maybe 1 meter distance. You can even use half a meter, even just a quarter meter. However, when you are comparing the two, you use the greatest common divisor. Yes, so let us have, you can start with 2. I know you have already paused and done your part to find the GCD, and then you check with what I have done. By 2, 42. 24 by 2, 21, 12. So of course you know it is 84. I'm dividing with 2, writing 42. 48 divided by 2, 24. 42 divided by 2, 21. 24 divided by 2, 12. You cannot divide by 2 anymore. You take 3. 21 divided by 3, 7. 12 divided by 3, 4. There is no any other number that you can use to divide the two. So the GCD is 2 times 2 times 3. 6, 12. That's the GCD. So what does 12 mean? 12 means is the distance, the largest distance that can be between these posts. Something else. I had told you to find the number of posts. Number of posts, the least number of posts that can be used to fence this farm. To get the least number of posts, you have to use the greatest distance. Lazima uweke hii distance ikwe kubwa. Otherwise, if you use a smaller distance, you are going to use more posts. So if you want to have least or few posts, you have to make sure that this has the distance is great. And therefore, you are going again to use this one. The distance that you have found is 12. So how are you going to use? You are not going to use this one directly. I know you can use, but let me show you the correct way. You have 84. So on this side you have 84 meters, and the distance between the posts is 12. So how many posts are you going to have here? You are going to have 84 divided by 12, that is 7. You are going to have 7 posts here. 7 posts. And here, 7 posts. What about here? You are going to have 48 divided by 12. 48 divided by the GCD. You are going to have 4. So on this end, you are going to have 4 posts. And here, 4 posts. So the total number of posts you are going to have 4 plus 7, 11. Plus 4, 15. Plus 4, 12. So you are going to have, sorry, not 12, 22. 4 plus this one is 11, 15, 22 posts. So total posts, 22 posts. It's important to understand how the question can be twisted. Now, let me use other examples on the same, especially. Don't know that I have. Yes, I have it. So I'm going to use the KCSE book to find a similar question. Yes. So this one is simple. I can give you your attempt because it can also be tested. Remember, questions that were taught in Form 1 in 844 are now taught from grade 7 and grade 8. There are 2 questions that I would want you to attempt. One is about the length number 18. And this one is solved in my channel. There's a video with this question. Yes, so attempt that question and then I can send you the link so that you can watch that video. Also attempt The question that we are going to do right now with you is question 23. Question 23. So I'm putting this way so that you can pause the video and read the question slowly. Now, question 23 reads, two bells ring at intervals of 35 and 42 minutes respectively. The bells ring together at 8:48 a.m. Determine the time when the bells will ring together again. So two bells, one rings at interval of 35 minutes, the other one 42 minutes. So the bells ring together at 8:48 a.m. We are looking at the next time the two bells will ring together. Yes, so we have used examples that require GCD. Let's see whether this one will use GCD or LCM. So, two bells A and B, one rings after 35 minutes. The other one, 42 minutes. So, both ring together at 8:48 a.m. So, let me just give you the scenario to try to illustrate this. Suppose this is what the timeline. So, both A and B, okay, let's put A here, A and B. So, and this one is 8:48 a.m. this time. So the next time A will ring is after 35 minutes. This one will be 35 minutes. Again, another distance of 35 minutes. This one, 35 minutes. What about B? B will be 42 minutes. 42. And another, continuing increasing this gap, 42. And again, 42. And maybe this one is becoming there, and so on and so forth. And we want to determine, something like this. We want to determine whether there is a point the two will ring together. The two will ring together. Because you can see they are alternating. This one, just 35, 35, 35. This one, 42, 42, 42. Probably there is a way this distance could get longer, sometimes get close, and so on and so forth. So first is to give you that scenario. Then, in other words, we want to know after how long, after how many 35s will be equal to several 42s. Let me do it again. Several 35s will be equal to this 42 times. So you are supposed to look at a multiple of these two, not a GCD, because you are not dividing. You are looking at the larger value. So the two will ring again together after how many minutes? After a multiple, the least LCM, least common multiple. It's a multiple of 35 mara ngapi na 42. So we are going to use this 35 and 42. Look for the LCM. So for the LCM, note it's different, a little bit different. Although I know you have done it, so you can pause and do the LCM. Yes, so I hope now you have already done. You're supposed to begin with the smallest value of the common prime factors. This is 2. This one is not divisible by 2. You drop. This one is divisible by 2. Up to this point, none is divisible by 2. You go to 3. 35 is not divisible by 3, but this one is. There is no other that is divisible by 2 or 3. You go to the next, which is 5. 35 divided by 5 is 7. This one is 7. So lastly you have that. So LCM. Note that in LCM there are times you can divide all of them, or sometimes a number you put here can only divide one number of the two, or if you have 3 numbers. However, for GCD, greatest common divisor must divide all. Here we are looking for multiple. So you have 2 times 3 times 5 times 7. You can use your calculator, or if you don't have a calculator and you want to learn also multiplying numbers easily, you can start with the larger ones. 3 times 5 is 35. 35 times 3 is 105. 105 times 2 is 210. So, what do you do with this 210? We are saying if bell A rings after 35 minutes and bell B rings after 42 minutes, the two bells will ring again together after 210 minutes. Yes, after 210 minutes. So, you convert this into hours and minutes so that you can add there and know what time they rang together again. Because we are told they rang together at 8:48. So you take 210 divided by 60 so that you convert to hours. By 3, 7 by 3, 2. So you have 7 over 2. 7 over 2 is 3.5, which is 3 hours and 30 minutes. This half you can multiply by 60 and you get it's 30. So you add 3 and 30. You add 8. 4 plus 3, 7. So, do we have minutes going past 60? But let's add kwanza. This one is 11. When you get 60, when they reach 60, you subtract 60. Because 60 is 1 hour. 60 minutes gives you 1 hour. So subtract 60 here. And you add the other end. So you'll have 12. And this one is 18. What if this was AM, PM? Because it has gone past noon. So there's a lot of thinking in this. So do more practice on the same. So today we have done numbers. We have looked at prime numbers. We have looked at total value, place value. We have also looked at LCM, GCD, and the applications. So the next videos we will look at other topics. You can always rewatch this video when you have a challenge in solving them. So it is important when the video is pre-recorded and is accessible to you anytime. If you have any question on this topic or any other topic, I'll be glad to hear and help you. So thank you. See you in the next lesson. Hi there. Have you subscribed to my YouTube channel? If you have not, chances are you are going to miss my next YouTube videos. So please subscribe and turn on the notification bell so that whenever I upload a new video, you'll be among the first to see my video. Subscribe, like the video, comment, and share with your friends. Yes, comment. Would love to hear from you. Thank you for watching. See you in the next video.